Hey guys, Mr. B here, and in this video we're going to be going through chapter 14.2 on work and machines. So let's get started here. First off, the main question we got to ask ourselves is, what is a machine? When you hear that word, you probably think of something made out of metal that, of course, runs on gasoline or maybe electricity, and it's big and, does all kinds of stuff. Certainly, that is a machine, but the definition of a machine is a lot simpler than that, okay? So a machine is any device that changes a force. So what does that mean? That's not what I meant to do. There you go. So what the heck does that mean? So here's a picture of an example. Okay, so this is a tire jack. A tire jack is basically something you put underneath the tire and you push it down and it lifts the car up off the ground so you can get under the car. And obviously, this is helpful because we humans are not strong enough to lift the whole car by ourselves. Unless, of course, we are like Superman or the Hulk or something. So in this picture, we have a tire jack. And what this tire jack is doing is it is taking the amount of force that we are applying to this handle, and it is applying it for us to the car, okay? And we are inputting a relatively small amount of force on this handle, and it is putting out a pretty large amount of force, right? Because I don't know if you ever used a tire jack, but they're not really that hard, right? You just kind of push down the handle. It's pretty easy, yet it's strong enough to lift an entire car up in the air. So it's clearly making our force bigger, right? It's making us stronger. Okay, that's what a machine can do. But it can do more than just that. So machines in general will change forces in a couple of different ways. Okay, but the tire jack, you apply force to it, it changes that force and it makes it a much stronger force. So therefore, this is a machine. Okay, but in general, machines make work easier to do. So a machine is anything that makes work easier to do, and it does so in three ways, okay, or one of three ways. One, a machine can change the size of the force that you need. So basically what that means is if you need to apply a really large force to lift the object, a machine can make it so that you only have to apply a small force, such as the tire jack, right? You put a very small amount of force on the tire jack, and it takes that and it makes it a really big force, and it allows you to lift a car. Another thing that a machine can do is it can change the direction of a force. The tire jack also does this. You push down on the handle, and the tire jack pushes up for you. So it takes your downward force, and it turns it into an upward force. So that's another thing that the tire jack does. But any machine can change the direction of a force. The third thing is it will change the distance over which a force acts. The tire jack also does this as well. Okay, so let's go look back at the picture to really see this one. So on this one, this red arrow here represents the amount of distance you have to push down on this handle. So you have to push the tire jack handle down maybe a good 2.5 feet or so. And on the other end, the tire jack is only going to lift the car maybe an inch, right? So you're putting in this much distance, and you're only getting out this much distance. So it's changing the distance over which a force is being applied. You're applying a force over a very large distance, and it's applying that force over a very small distance. Okay, so machines can also do that as well. So if something does any of these three things, it is a machine. Okay, that's how we define it. So it doesn't necessarily need to be made out of metal and run on gasoline or electricity. So increasing force. So a machine, again, is able to increase your force. We already looked at that with the tire jack. We'll see this picture again, though. So each push of the handle takes a small force, applies it over a large distance, and it turns that small force into a very large force. Okay. So it says if a machine increases the distance over which you have to exert a force, then it decreases the amount of force you need to exert. So what this is trying to say is this. Distance and force are opposites from each other, okay? So if you have a machine that can make you stronger, so it takes your small amount of force and it turns it into a big amount of force. The downside is it's going to take that large amount of force and it's going to apply it over a very small distance. And that little force that you put in, you're going to have to apply that over a large distance. So again, in the picture here of the tire jack, we apply a small force over a large distance. And we get a very large force out, but over a very small distance. Okay, so they're always opposites. So again, we see small force, small distance, large distance. Okay, always opposites from each other. That's something that we're going to have to remember. It's a pretty important piece when it comes to machines. So some machines can increase the distance. Some machines can increase the distance over which a force is applied, or it can decrease the distance. So there is a picture of a ramp on the following slide. All right. Well, there's supposed to be a picture of a ramp here, but there's not. So we are going to Google a picture of a ramp so we can see what this is talking about. Okay. So let's go pull up a ramp. Let's go to images. All right. So let's take a look at a ramp. So what does a ramp do? Now this seems sort of silly because you're like, well, I know what a ramp does. You use it to push things up, get them upstairs or something. Let's think about it in terms of machines. Okay. A ramp. What a ramp is doing is it is lifting an object for you, right? We use ramps to lift objects up to higher elevations, and instead of having to lift it and put it up there, we push it up a ramp instead. But essentially, all this ramp is doing is it's taking this object, which might be down here on the ground, and lifting it to be up here on top of the stairs. Okay, that's what a ramp does. So a ramp is increasing the distance over which you have to apply a force. If you were to lift an object from the bottom of these stairs to the top of the stairs, it might be like 3 feet. However, if you were to push it up this ramp is probably more like 6 feet, right? So it's taking a small distance that you might have to lift this object, and it's increasing that distance so that instead you have to apply it over a long distance. However, again, the nice part is it's a lot easier to push it up the ramp than it is to lift it straight up off the ground. So what the ramp is doing is it is increasing the distance over which you have to push an object, but it's decreasing the amount of force you have to apply. So it's easier for you to push it, okay? Again, that's what the ramp does. So it is increasing distance, and therefore it is decreasing force, okay? Because those are always opposites from each other. So, all right. Now, this is a picture of a lever. Okay, so this is a picture of an oar, someone rowing a boat, which is a lever. And we'll talk about levers and ramps and stuff more in the next section, but regardless. So each oar here represents a machine, okay, and it is a lever. And the reason why this is a machine. So let's understand, like, why is an oar of a rowboat a machine? Like, it's just a piece of wood. How is this a machine? Well, think about this. You have to apply a very large amount of force, okay, to pull an oar. If you ever had to row a boat before, it's pretty tiring, okay? I mean, there's a whole sport called rowing where, like, people in professional rowers are, like, doing this. And, I mean, their arms are jacked, by the way. If you've ever seen a professional rower, they're, like, super muscular. So you have to apply a pretty large amount of force, okay, to do this and pull this oar. The amount of force that the oar gives you out is actually a lot weaker than what you're putting in. However, here's what it's doing for you. It's taking a very small distance, and it's making that small distance a much larger distance. So you only have to pull the oar like from here to your chest, right? This might be like 2 feet, maybe 2 feet. But on the outside here, it's taking that 2 feet that you're pulling, and it's turning that into like 7 feet. So every time you do this, the oar is pushing, this much water for you, which is a lot, and essentially allows you to go through the water a lot more quickly and efficiently. It also is changing the direction of your force. If you pull this way, okay, right, so you're pulling towards your body, the oar is going to push opposite, right? It's going to push that way. So if I go like this, the boat's going to go that way, right? So it's giving me opposite direction as well. It's changing the direction that I'm pulling, or that it's moving my object. So this is considered a machine also in that regard, okay? But this machine, again, is decreasing the distance through which you have to exert a force, and it increases the amount of force then that you are required to put in. So you put in a pretty large amount of force, it gives you a small force out, but it's taking that small distance and it's turning it into a big distance, which is essentially pretty beneficial for us. So, all right. And then again, we've already talked about this now a couple of times, but last thing a machine can do is change the direction of your force. So again, in the previous picture, you are pulling back on the handle, but the oar is moving in the opposite direction, which then causes the boat to go in that direction. So it can change the direction of the force you're applying. All right. So now that we have an understanding of what a machine is and what machines can do, how do they make work easier? So we have two things we got to talk about here is work input and work output and how they're related to a machine. So we need to understand that machines make work easier to do, okay? But because of friction, remember there's always friction on us, static friction, sliding friction, rolling friction. Because of friction, the work that a machine is doing, which is what we call our output work, is always going to be less than the amount of work that we have to do on the machine, called the input work, okay? So input force and input work, this is the amount of force you have to apply to the machine to make it do something. The input distance is the amount of distance you have to apply that force on the machine to make it do something. If we take that force and we take that distance and we multiply them, this is what we call our input work. Okay, so it's how much work you are doing on the machine so that the machine will do something for you. Likewise, output then is what the machine is doing. So output force is how much force the machine is applying on the object for you. Output distance is the amount of distance that machine is applying that force on the object for you. And our output work, our work output, is that output force times that output distance. And that again is how much work the machine is doing for you on the object that it is doing whatever you're trying to do on, okay? So again, because of friction, the amount of work that a machine will give out will always be less than the amount of work you put in. So if I put in, 100 times work, the machine's only going to give me 99 times at best. It might give me less, okay? It could give me 95 or 50 or something really bad, but it's never going to give me 100. If I put in 100, it will never give me 100 out because some of the work that I put in is being used just to overcome friction. And we'll talk more about friction in the next section, but this is the reason why we have things like lubrication, oils, and grease, and why we have things like ball bearings and stuff that essentially reduce friction, which then make machines more efficient and work better. So, all right. Anyway, so hopefully that gives you an idea of what a machine is and how machines work. No pun intended there. But again, if you have any questions, make sure that you reach out and ask. So, all right, guys, that's it for this one. I will see you in the next one. Bye.